All right, let's do another question here. For this question, we have some objective, and the goal is essentially to run one step of gradient descent. Right, we start with W0, and we want to run one step of gradient descent and figure out the next step. And then after that, you want to figure out what B is. So this is like the easy version of SVM. So how will we go about doing this? Well, if you want to run gradient descent, the first thing you need to know how to do is find the gradient. Right, to find the gradient of this, we'll start with the first one. Well, how do you find the derivative? So W, well, we'll start with here. W is equal to W1, W2. Therefore, this right here is the norm of W would be square root W1 squared plus W2 squared. And this whole thing is squared, so square. So if it's square and the square root cancels each other out, what we have is W1 squared plus W2 squared. So essentially this term here is equal to this right here, this right here. Now, if we want to take the derivative with respect to W, so dW of W1 squared plus W2 squared, right, is equal to the dW1 dW2. So this, well, we'll call this the function. This right here is the function. df dW1 df dW2. So what is the derivative with respect to W1? Well, it's just 2W1. And with respect to W2, it's just 2W2. So this tells us that the derivative dW for L2 norm square is just 2W. So okay. So we now know the derivative for the first part. Let's find the derivative for the second part. Actually, maybe I'll write it over here instead. So for the second part is quite easy. It would be I all the way to n. What we have is lambda y1 yi w transpose xi minus, actually it's a plus lambda yi b. Did I do that right? Yes, I think so. Well, now we want to find the derivative with respect to w. Since there's no w here, that just cancels out. And over here, these are constants. I mean scalars, right? So the xi is a vector. So you just really need to look at this part here. So this part here, when you take the derivative with respect to w, you get lambda yi xi. I equals 1 to n. So this is the result. Now, for those of you that didn't remember how we did this, how did this, like if you have W transpose xi, right? Well, in general, if you have some vector times x, and you want to take derivative with respect to w, you can see this as you have w1, w2 times x1, x2, and this becomes w1, x1 plus w2, x2, and now you take derivative with respect to w is equal to dw1 df w1 df w2 Now if you take derivative with respect to w1, you just get x1. And then with respect to x2, it's just x2. And this is why when you do this, right, you end up getting x. So ddw, w transpose x is just equal to x. And you can see the reason why that's the case. So anyways, let's continue. So yeah, so this is the derivative, and that's basically it. It's not that complicated. So now, if we put them together, if the loss function, we have dl dw, which is equal to 2w minus lambda summation I from 1 to n yi xi. So that should be it. So now we have the derivative. So once we have the derivative, what do we do? Well, we want to run one step of gradient descent. So gradient descent is, if you start with w1 is equal to w0 minus eta dl dw at w at w0. There we go. So this is how you do it. So now we have the equation for w, the dl dw. So let's see, what did I say? W step size is equal to 1. Okay. And w0 is 1, 0. So we're going to say this is equal to 1, 0 minus 1. And we're going to plug, we need to plug the in dl dw, and we're going to plug 1, 0, right? Because that's w0. Right, w0 is 1, 0, correct. So if we plug that in, let's make this up. Okay. So we plug this in is equal to 2, 1, 0 minus, did I give a lambda value? Lambda is equal to 1. And then we need to do a summation. So what's y1? Y1 is minus 1. So y1 is minus 1 times x1. So y1 is minus 1 times x1. x1 is 1, 0. Yeah, x1 is 1, 0. And then it's going to add that to y2. y2 is 1 times x2. Is 3, 1. Okay. So let me write this a bit smaller. So this goes right here. Yeah, let me write it even smaller. There we go. So if we plug the first point in, w0, we should get, following this equation, we should get, let me see, I think this looks right. The first point, the second point, yeah, this looks right. Right? So this is equal to 0 minus, what is this? Minus 1, 0 plus 3, 1. Let's see, did I do anything wrong? That looks right. Okay, and then let's combine it again. 2, 0 minus, I think it's 2, 1. Alright, that's 2, that's 1. Okay, so now the result would be 0 minus 1. Let's see. That looks right. So now we finally have this. So we can plug this in. We can plug this into this term here. So W0 times 1, and you have 0 minus 1. Well, this is just minus, plus, and plus. This means it's 1, 1. So this is equal to W1. Okay, so that's the idea. Let's see. Now that you have W, so we calculate the derivative. That was this here. And then we calculate W1. Okay, so we also, that this is right here. So we know the derivative, we know W1. Now, on the blue book, when you write your answer down, make sure you mark the solution, because if we don't see it on the final exam, you don't get to argue, you just get a grade. So make sure you make it very clear where the answer is. Anyways, so I mean, for gradient descent, the whole point is find a derivative, then take one step of gradient descent, and then after that, you have it. So the part 3 is B. So how do you find B? Well, B, that requires a little bit of drawing. So right now we have 2 points, right? 1, 2, 3, 1, 2, 3. So it's 1, 0, and 3, 1. Right, so these are the two classes, right? Red and orange. So what is telling you is after one step, you want to project it onto 1, 1. So 1, 1, the line looks something like this. So after you do the projection, you find the middle point. So how do you find the middle point? I mean, you need to find this point, and you find this point, and then you need to find the center. So now you need to do a projection. So this is why this point is worth 200 points. All right, this one is worth a lot. So how do you do projection? So you have 1, 1. Let's call 1 V. Okay, V is equal to 1, 1. But when we do project onto 1, 1, we need to make sure it's normalized. So if you normalize it, V is equal to 1 over square root of 2. Okay, so that's the normalized version. So next you want to find x1. So if you project x1 onto V hat transpose, and then multiply by V hat. Okay, so that will give us this point. Now if we do, we'll call this P1, P2. Okay, so what is P1? Well, x1 is 1, 0. Let me see. Yeah, x1 is 1, 0, and then it's projecting onto 1, 1. And then you multiply this whole thing by V hat again, which is 1 over square root of 2, 1, 1. Okay, so that's what we're trying to do. Let me move over a bit. Well, this right here is equal to 1/2. So that and that cancels out, right? 1/2. And then this and this is just equal to 1. So that's it. And then you have 1, 1, resulting in 1/2, 1/2. Okay. So this should be where this point is. 1/2, 1/2. And you, by looking at it, you can kind of see that 1/2 for P2. I mean, I kind of screwed it up. This should be P1, P2. So for P1 equals P1. Now for P2, we do this again, which we have. So for P2, 1 over square root of 2, 1, 1, and x2 is 3, 1. So 3, 1. And that whole thing multiplied by 1 over square root of 2, 1, 1. Okay? So this gives you 1 over 2. This and this cancel out. This one would be 4, right? This times this is 3, 1, that should be 4, which gives us 2, 1, 1, which is equal to 2, 2. So this point right here should be 2. This point should be 2, 2. And if you look at it, it also makes sense that it's 2, 2. All right, so we have 1/2, 1/2, and 2, 2. We just need to find the center. Right? What is the center? The center is 2, 2 plus 1/2, 1/2. Like you add them and divide by 2. And then divided by 2. Okay? So this is, let's see. So this would be equal to 1, 1 plus 1/4, 1/4, which is equal to 5/4, 5/4, 1 1/4. So if you look at it, 1 1/4 makes sense. 1 1/4 makes sense, right? I mean, I didn't draw it perfectly to scale. So the B is in the middle. So this right here is B. And now we have 5/4, 5/4. And that is the question. This, I mean, it took, I don't know how long it took. How long did it take? Do I have a timer? I don't have a timer. But it shouldn't take you more than 10 minutes. I basically, I did a lot of background derivation so you know how I would get them in the first place. But if you have the conclusion, you can essentially jump to the solution. So this is how you do this question. Hopefully you got it.